Okay, so first of all, I would like to thank you for attending this lecture. There were 3 others to choose and you made the right choice. So today I will be talking about code reviews. And before I proceed to that, let me just say a few facts about myself. I have Masters of Science in Computer Science. I am working in STX since very long ago. I am doing Python and JavaScript. I am giving talks at different events. I had a competition, the riddles, last year here at PyCon, and I'm also sometimes presenting at other events like the local Python programmers group in Poznań that is called Pyra. I'm also doing internal trainings from both JavaScript and Python at the office back in Poznań, and I'm also a lecturer at some postgrad studies, also in Poznań. And a little fact, I'm a CPython contributor thanks to some effort in the last year's EuroPython. So what will we be talking today? Well, we'll be talking about code reviews, and we'll start by saying what do I mean exactly by code reviews? What kind of code reviews we'll be talking about? I will try to tell you why we should do code reviews if somebody is not convinced yet. I will try to point out some things that differentiate a good code review from bad code review. And I will try, at least I will try to present how do I do it, and I hope I do it right. So I hope I will try to convey to you how to do those reviews in a good way. There will be a huge portion of the presentation that will contain samples, and all of those samples are actual code reviews that I did in the last year. Most of them are coming from me. They are not signed, so don't worry, guys. There are some people here who were under the review, but don't worry, there are no names. What else? All the code samples that will be shown are actual code samples, sometimes adapted a little bit to make what I want to show more obvious. And I will try to convey also some conclusions at the end. So what is a code review? Well, when I think code review, I'm thinking about some very specific thing that I do on a daily basis. But then to prepare this presentation, I also looked on Wikipedia, and it turns out that some people have a very different idea about code reviews. There's this notion on Wikipedia of like formalized code reviews that you just have a meeting with few people, and you are going over somebody's code in a group, like, you know, very formal, step by step. This is not what I do. But what is making me able to talk to you about code reviews? Well, I'm doing Python for 7 years now, JavaScript for a little bit less, and lately it is one of my main things that I do in the office. I am overseeing right now 2 Scrum teams, and I'm doing review for those teams. And most of the review that goes into the project goes through me. There are about 14 people, different times there are more, there are less. And sometimes it is like a full-time job. I had a sprints, 2-week sprints or 3-week sprints where I didn't even do any like stories of my own. I was just doing reviews. So I am doing this a lot. And also, if somebody was applying to STX Next like few years ago, they probably got their recruitment challenge reviewed by me. But that was long ago. Okay, going back to code reviews. What kind of code reviews am I talking about? Well, first of all, informal. I don't have a checklist. I don't have a document to fill after I do the review. I do them individually. It means there are no other people sitting with me doing the same stuff. I do them in my own time. That means that it's not like I come to the office and since 8 till 10 I do code reviews and then I do something else. No, whenever I find some time, I do them. Usually it happens whenever I need to take a break from doing my own task, if I'm so lucky to have one. But yes, at any time I want and how long I want. And also I love the fact that right now the reviews are tool assisted, that I am getting email notifications, and that as soon as somebody posts a pull request, there is a vulture waiting to just get into it. One other thing, we are working using Git, and we are doing feature branch. So for each change, for each story, for each bug fix, you create a new branch, you work on that branch, and that branch, all the changes from that branch get reviewed. We don't do commit by commit reviews because those are pointless. Stuff changes too much. And one more thing, what we implemented is that there need to be at least 2 sets of eyes for any pull request to be merged. So you need at least 2 looks good comments to get your pull request merged. Now, why do you do code reviews? Well, I think there's quite consensus on that. People do it for code quality, whatever that means. But how else can you express code quality? Well, you don't want somebody who just joined the project and previously just heard about Python on some lectures at university to push to your very important production repo. So you need some kind of filter to get the bad stuff, not pass further. Is it important? I think it's very important. I don't think people who are coming into the project, even if they are good, they still might not adhere to the standards of the particular project. There are some conventions, there are some ways of doing stuff in particular project, and even if you are a senior Python developer, you come into the project, you will try to do it your own way, but there's a preferred way that we are doing this in the project. So still it's good for somebody to look over your changes and say, well, this needs to be different. So what other things apart from code quality? Well, the standards, like I said, when the project is being developed for some time, some standards are just created, and after some time you just know how to do stuff. Like you want to do logging, you know how to do logging. You either use some logging solution from the project or use the standard logging mechanism. You either use the % formatting or you use .format. It's this stuff just gets developed when the project is running. Other thing, knowledge sharing. The teams that I have now have in total about 14 developers. So it's not so easy to communicate what everybody is doing at all the times. There are 2 Scrum teams, so the 2 teams, they don't even have common stand-ups. So it's not like everybody knows what's happening. But those pull requests and code reviews are a good way to learn what other programmers are doing, even on the other team. You just know what they are doing, how they are doing it. You might learn from looking at their code how some stuff can be done. Like somebody uses this cool feature from Django that you didn't even know about. Well, you can learn, and next time you need something similar, you just do it just like they did. Ownership. This is also pretty important. We have this notion that whatever code we write, it's our code. Well, that's cool, but it doesn't help the project in the long run. You are going for long vacation, like 2 weeks somewhere off in Malaysia, let's say, and turns out that there are some bugs that are found in your code. So the team will be like, oh, I'm not touching his code. He will kill me. No, that's bad. That should not happen. What should happen is that the code that you wrote is common property, and at least the 2 people that reviewed it are also responsible for it. If something breaks, if there were some very obvious mistakes, it means that the reviewers were shit, that they didn't do their job right, and they will be also kind of motivated to fix the mistake. Not to mention that they will know what was being done there. They will have some knowledge about the code. It's not like they will dive into something they see for the first time. No, they've seen it, they've probably analyzed it, and they kind of understand it if they said it looks good. Hopefully. And the last thing is you get feedback. If you are an inexperienced developer, you get your pull request reviewed, you get some comments, and you can learn from that. You do something wrong, they tell you that's shit, you do it better next time. You do something good, and somebody says, yeah, that's cool. It's cool that you use that generator here, that's very good. And you also feel appreciated. So, now, about good review and bad review. Do you think that there is such a thing as bad review? Well, there are certainly some things that can be a little bit annoying. But I think that mostly code reviews are a good thing, even if they are annoying at times. So what kind of annoyances you can encounter? Well, there's always Captain Pep8, the guy that just runs Pep8 on your pull request, and if he finds something, he posts. There's Major Line Break, the guy that says that you can break this line differently because then it would be more readable. There's Lieutenant I'm Wrong, that's the guy who is posting stuff, but he's not really right. He's just posting stuff that is plainly wrong. And there's Unicode Man. You are doing some stuff in Python 2.7, and guy tells you that you should have used Unicode for that. It's very annoying, but there's sometimes you have Internalization Boy. That's the guy that says that you are not using the underscore to translate your strings. There's Missing New Line and the End of the File Woman. That's the most silly thing I have encountered so far. But we had those comments in the code, but I don't know how you can bother to do this, but some people do. And there's always the common grammar Nazi telling you that your English is shit and you should write it differently. But the question is, are they really bad? I think even though they are annoying, they introduce some value to the project, except maybe for the missing new line at the end of the file woman. But all the other stuff, like the Unicodes, it is annoying, but if you cannot differentiate between byte strings and Unicode strings, then you plainly don't understand the data types of the language. That is like very fundamental. So I think even though this is annoying, it's still good. But what is the worst kind of review that you can get? And I would like you to think for 5 seconds. I hope somebody figured it out. That's the worst kind of review. That somebody looks out at your code and he doesn't notice any mistakes. It's like, you know, those like 3 monkeys, one cannot hear, one cannot see. Yeah, this kind of situation, that somebody just doesn't see the evil in your code. I think that's the worst thing. If you push some shit and people say it looks good, that's not really beneficial for the project. You need some criticism if you do some stuff wrong, and you cannot develop yourself like personal development if nobody tells you how to improve. So I think comments looks good when stuff is not good. They are very, very bad. So how do you do code review nicely? Well, I believe that tools do make a difference. What does that mean? We have struggled with some tools in the past, and only after you get the tools right, the code reviews can proceed smoothly. Other thing is that you need time for code reviews. It's not like when you get a complicated pull request, you cannot really review it in 15 minutes, or just, you know, in between you go to the toilet and then go to get some coffee. That's not how it's done. You need to have some time for it and really concentrate on the task. You need to allocate enough time to look through all of it. There are some pull requests that take shorter amount of time to review. There are some longer ones, but you need to have enough time to look through all of it. I don't believe that looking like half through it and then another quarter and then another quarter is good. Just allocate enough time to look through all of it. Do it once, but good. And this is something that my university professor taught me. I don't know, maybe there are some people here in the room that know David Weiss from, he was teaching at Polytechnics in Poznań. This is something that he said, you should never run the code that you are reviewing. Why? Because it gives you the false sense that the code is good or that it works. That's not how you should do. It's not like you run it, you see, oh, it worked for this scenario that I started, so this code must be good. That's not true. Code is shit because it doesn't support 8 million corner cases that you can easily see looking through the code. When you are doing a review, you should analyze the code, find the corner places by using the Python interpreter built into your mind. And you should always have a rough idea about what the code is trying to implement. Usually you would get, the code will be implementing some feature that is described in your issue tracker. You should definitely look at that before you start reviewing, because otherwise you just see some code that is doing something and you learn what it's doing by looking at the code, but maybe it was supposed to do something very different. Okay, so let's talk about the tools. When first we started doing this, we tried using a review board with uploading the patches to it. That was very bad. We had cases where people spent half a day literally trying to upload the patch to review board. That's not how it's done. If it takes too much effort, cannot be done. In the next project, we had another attempt with the review board. But we had some scripts, so we're already working on feature branches, and we had some scripts to do that. It was better, but still the tool was not that great, and it took an effort to create the pull request because you had to like start those scripts and also pass in some parameters, whatever. So what I think is private GitHub for the win. I have tried also Bitbucket. I didn't like it that much. It seemed much slower, but at the office we are using private GitHub and it's great. It's really nice. It's very clear. It supports all the stuff that you want to do. It's pretty intuitive and I just love it. Makes my work pleasant. So how does it look? Well, you have a section with pull requests. You have here an example pull request. You get to write a description that you should probably take some time to write nicely. Put some description saying what this is, link to your issue tracker. Then there's a section where you can browse all the comments and all the diffs. And the nice thing is that once you push some changes to the branch that was under review, it hides all the stuff that gets outdated. So I comment on something and somebody fixes this. So later when I refresh, I don't see those outdated comments of mine anymore. That means, you know, I don't have to look through all of the history because it filters it out for me. It's great. And the diffs are pretty nice. Here, a little bit up, you have like traditional diff, and here the very nice feature that not every diff tool has is it shows you what changed in the particular line. So it might be not that visible here, but this is like highlighted that only this bit changed. It's pretty nice, and it makes working with it and looking through it the whole day pretty not exhausting. And also you can write comments, and in the comments you can embed some formatting. If you want to put some code, there's markup for that, so you can format your comments nicely. So let's talk a little bit about the numbers, the stuff that I'm doing. The pull requests, they take different amounts of time. There are some little ones, some little bug fixes, like somebody fixes, for example, some styles. Somebody pushes a little change to CSS. Well, I don't know CSS that much, so for me it doesn't take 15 minutes to look at it because I don't understand it that well either way. There are some bigger ones, some more serious ones that take between half an hour and 1 hour, and there are also massacre pull requests that take half a day. What's that? Well, we've been doing this. We had a legacy project, and at some point we decided we need to get rid of all the PEP 8s. So there was one guy doing PEP 8s on the whole project, and he was pushing like 8,000 lines of code changed. That is really not nice to review. It's just killing you. When we do our sprints, usually you are able to do about 1, maybe 2 at most stories during the sprint. So you release about, every person on the team releases about 1 or 2 pull requests per sprint. And I also did some statistics checking. I checked how many comments appear on pull requests, and it turns out that it's between 9 and 10 on each pull request, and it depends. The one that had the most had 42 comments. I believe we had some that had more. I remember back in the day we had some that were over 100, but then I think we were just trying to be nasty. But there are also some that just have like 2-3 comments and they're getting merged. And I've measured this on the last 50 closed pull requests in our project. So what rules should you look at when doing pull requests? You should link to the issue in your issue tracker. That's very important. The code that you write, it should be tested. The pull request should be functionality plus tests at all times. You should assume that PEP 8 passes. That means the guy who's doing the review, he won't be doing PEP 8. There are tools who can do that. It takes less than 1 second to check PEP 8s on your project. So why would I do that if the machine can do that better? I'm assuming that you run your tests, so I'm not running the tests for you. If the tests break, it's on you. It's not on the guy reviewing. And as I said, each pull request needs to be reviewed by at least 2 people. And the original developers of the changes, sometimes there are 2 people working on the same story. They should not comment on each other. That's bad. And also we have this rule that you shouldn't close the pull request very fast. It's not like it gets published 5 minutes and is merged. No, it should be left there to settle for a bit, for people to have the chance, the free 15 minutes to look at it and have a chance to comment. And try to not be nasty. People don't like being nasty. I think some people in the team think that the reviews I do are not that nice all the time, but I'm trying to not be nasty, actually. And if I'm nasty, why am I nasty? Well, why am I pointing out every little thing? The stuff that doesn't even matter. We have some list that has like 6 elements, and you are saying that, oh, this you can do with the generator or something. Well, we are not creating monumental stuff every day. The stuff that we do every day is like normal stuff. It's like simple stuff. If we would be doing the very big stuff that needs to support 10,000 clients simultaneously, it will be very important, but we don't have this opportunity every day. So we need to learn on the stuff that we do every day, on daily basis. Even the simple stuff. This is the only opportunity to point out the things before you proceed to making your monumental changes. So you need to learn all those simple stuff before you can proceed to the big ones. And even if this code would work for those 6 elements in the list, still maybe you should take a bit of time and make it just better. If not for the benefit of the project, then for the benefit of yourself, to just learn something cool and new. And I believe that enforcing discipline is a road to enlightenment. If I point out that you should put Unicodes in your text strings, 20 times a day, then maybe people will finally start doing that. Okay, and few tips when you are doing the reviews. I think it's quite nice to show people how you can do stuff. If you just tell them this is wrong, this is not really teaching, this is being nasty. But if you say you can do this in a better way, like this, learn from me, this is better, people can take something from it. When there are few, the same thing happens over and over in the pull request, the same error is reproduced, don't put the same comment in all the lines, just say ditto, it means the same. So you found another instance of the same thing. Don't try to, point out that you didn't put Unicode 100 times. And if it happens that somebody didn't put Unicode in 100 places, just point it out once and then say, also fix it in the other 99 places. Don't put the 99 comments. It's, I think, a little bit annoying and doesn't really help that much. So, now the fun part, the samples. There are a few levels of comments that you can have, depending on the skill of the reviewer, I think. There are some stuff that even beginners can point out, there are some stuff that intermediate guys can point out, and there are some stuff that mostly the senior guys can point out. So, what are those? Well, the beginners can certainly point out PEP8 violations. That's not very hard. Beginners can point out that you can break the line differently, although they probably shouldn't. People can pretty easily spot that there are some Unicodes missing. But there's another thing to this. Some people take this a little bit too far. They don't really look at what's happening, and they change Unicodes. They change to Unicodes everywhere, when it doesn't really work like that. This is a very common mistake during some refactorings. When I say you should introduce Unicode to that string, they introduce it, but only to the first line, and then the second line is a string, and this is a pretty common pattern that you can spot. Also, I should mention one thing. Those diffs that you see here, this is the stuff that I comment on. So it's not like the red stuff is bad and the green stuff is good. No, this is just the diff of the changes that I saw, and I noticed that something was wrong in that line. It means that in the green line probably something was wrong. Okay, the beginners can also point out that something doesn't adhere to the conventions that we use. For example, in our project, we prefer to use format over percent encoding. Very simple thing to point out. Missing dog strings. Anybody can point out missing dog strings. You see a function, doesn't have a dog string, comment on it. Very easy. So this stuff that I showed is everybody can do it. Probably machines can point out most of this stuff. I believe PyLint can be a big help here. Now, what about the stuff that is a little bit more intermediate? Well, it sometimes happens that people use some stuff wrongly. Like here, for example, format is used when formatting logs. That's not how it's done. Logs support the percent formatting, and then you put the arguments after the comma. You don't format the string on your own. It's quite convenient because if by any chance you have some Unicode decode errors or something, the problem with the logging, it won't break your application. There will be just a warning printed to the screen that something went wrong with logging, but your application won't break. So this kind of stuff. People use something, but they don't use it correctly. It's cool that they use logging instead of print, though. Also, people that are on the project for longer, they can point out stuff that doesn't meet the convention of the project. We had a big discussion how you should do fixtures, and people were saying that you should not actually refer to the objects that you have in the fixtures by IDs, that you should select by attributes. So instead of looking for a submission with primary key like that, you should rather try to look for a submission with specific title or meeting some other specific criteria. It's something that we had on our project. I don't think it was good, but that was the standard, so people who are on the project longer can point out this to you. Some other stuff is when people try to hard code stuff into the code. Here, for example, is like a full path to an image, and of course the static prefix is configurable in Django. You can change that by using the settings file. So putting that into your code is not really good practice, as this can be changed. Also, this is stuff that not everybody can spot. Very nice comment is that there are no tests for this change that you are doing. Sometimes people push pull requests without any tests. That's very easy to point out. But sometimes they don't test some of the changes they do. And it's nice to remind them that the tests are nice and they bring value to the project. Very often I find myself in this position where there's a complicated bit of code that I look at during the peer review, and I don't understand. And if that happens, it's not like I think to myself, I must be stupid. No, it means that the code is overcomplicated or is not explained well enough. It's nice to tell people, put a docstring here. It will help the developers in the future. Also, sometimes I am pointing out to people when they make some language errors in the comments. Not everybody speaks English. Not everybody does that well, and sometimes you get comments that you don't really know what they mean. So if that happens, it's good to tell them to change it, so people will understand it later on. Very nice thing to do is point out to people that they can use some stuff from the newer versions of Python or from the newer libraries. People, when they learn Python, they usually stick to the stuff that they learned that was available when they started. But there's cool stuff coming in every day. Just yesterday was the lecture about Python 3.4 and what's new. And I believe you should use it right away when it's released. So it's nice to point out to people that they can use those new features as soon as they can. We use Python 2.7 on our project, so I'm very much for pushing to use the future imports. There are some other things that also people don't use because it was not available when they were learning Python. For example, set literals. They were not there in Python 2.5, I believe. But now you can use them. So whenever I see a change that is operating on stuff like this, I point out that you should use the set literals because that's the new way to do it. Another thing, dict comprehensions. We have lots of this kind of expressions in our code because it was developed before dict comprehensions were available. But they are cool and you should use them, and I encourage people to change all those to dict comprehensions. Now, a little bit more complicated stuff that probably not everybody can point out. So, cool things. When you are an experienced developer, you've seen so much. You know so much, you've seen everything. You know all the Python library by heart, but not everybody does. Here is an example of a pull request with changes to, well, actually less. Not CSS, but less. And even though I'm not a front-end developer, I noticed this code and I can see, oh fuck, this is very repeatable. Why would you do that by hand? And I looked a bit on the documentation of less, and of course there's something that is called parametric mixins that you can use to generate this much quicker. You just write like a function that generates all this stuff. So pointed out something that can be used to ease your daily struggle. This is very important. You get some code, and it has some ifs, it has some conditions, it has some for loops, whatever, and you ask the very important condition, a very important question: will this work in the following conditions? You are thinking how this code can be broken. What are the corner cases where this can go wrong? Here, for example, there is like a nested mustache rendering thing, and the condition is while there is the nested template tag in the output, you should still render it. But what if somebody just puts this into the form, this kind of this sequence of characters? Well, then this will probably break, and the original developer did not think about that. Even better, if you can provide those corner cases, you say this is the condition where this will break. People don't always, the original developer doesn't always suspect all the instances where stuff might happen. So if you can point out to him when this will fail for sure, it's great. And sometimes you can point out that in something that they haven't tested properly. Like here is some date validation, some complicated rule, and if you spend a little bit of time reading through the issue in your issue tracker and learning what was it supposed to implement, then you can think about this this one particular instance. Yes, that on Sundays you cannot pick Tuesday. You can point out this to the developer. It's very important because this prevents bugs from production. Also, you are more of an architect when you're a more expert programmer, so you can point out to people that they can refactor their code in a different way. You can tell them this is like repeatable, extract this to a helper, because this can be used somewhere else. Here, for example, is the classic save get that was implemented inside the function. Why? This is like, it's not part of the logic itself, it's more like a utility. Python has very cool features for all the while loops, for all the for loops, for the try statements. Not many people use else in for loops, for example. Not all people use else in try statements. I love them. They make the code so much better. And whenever I see code that is struggling with supporting exceptions or can be refactored very easily by using else in a for loop, I try to enforce that. Sometimes I encounter some stuff that is like this. It's doing some strange stuff with some indexes, trying to achieve something. It's like impossible to understand. I was looking at this for some time, and it's like very, very hard to understand. And if it's hard to understand, it's probably buggy because there's some stuff that you didn't think about when you're writing this. So you can point out to people that this is too complicated. They need to simplify. They need to do it in a different way. I'm also trying to point out to people that they can do stuff more efficiently. If there's a possibility to use a generator expression, for example, instead of materializing some stuff, then I point it out. Why? Here it doesn't really make probably that much sense because there won't be thousands of those elements there. But like I said, this is teaching. I'm trying to teach you stuff. When you'll get to the point where you will have 1,000 elements, I don't want you to use a list and materialize them. I want you to use a generator because that's how you've been taught. Another stuff, when people write stuff, I can think how this can be done simpler. In this particular bit of code, a guy was doing something that can be done much easier and be easier to debug. Instead of checking all the conditions and then later on have like one assertion that checks if all of them passed, you can just check the condition those n number of times, and you'll get easier to debug messages if stuff breaks. Of course, when you see that anybody uses permutations, this code cannot go to production at any cost, probably. So it's good for you to know how those algorithms behave. Not only permutations, this is a very extreme case, but some other ones. That looking through a list to find an element is not that efficient. You should probably use a dictionary or a set if you will be looking a lot. So it's good to point out to people that they can reduce the computational complexity of their code. And also any pointers on efficiency. Here, a guy was getting all the data, all the objects filtered from Django, and then he was just using the IDs of them. Then why would you get all the objects? It takes a lot to take them from the database. You need to get all the columns, and they need to be parsed into Python. That's pointless. You can just use, for example, here something value list and get the IDs straight. The query to do the database is better. It's better. It's more efficient with memory. It's just better. So if you can point out that something can be done more efficiently, please do it. If you know that something can be done more easily using a particular data structure, usually a set or a dictionary, point it out. This is good for efficiency, and people should get to know this stuff. Not everybody that programs in Python has ever used a set, but they're so useful, they're so nice, they're great. You should use them as often as you can. And of course, this is the last example. Sometimes people write stuff that is too complicated. This was some date validation stuff. It was also something about that you need to have some stuff 2 days in the future, and this cannot be when it's the weekend and 2 days in the future. No, it was supposed to be the next day, unless it's a weekend, then it needs to be the day after the weekend. But also the working day changes at 6:30, I believe. Yeah, 6:30. So after 6:30, you cannot do it for the next day, but you need to do it for the day after, something like that. The condition is not trivial. This is what a colleague of mine came up, and there are 4 conditions. There is if, there is else if, and else. And I'm talking right now about the red bit. And each of those ifs, it has 3 different conditions. There are always 2 ends in it. So this gets crazily complicated. If you try to analyze this, it's like impossible. How will this work? If you try to imagine it, it's like not possible for you to do. So I came down and sat with the developer, and I drew a Carnot table, like I've been taught at the beginning years of the university. And guess what? It turns out that you can actually minimize this complicated expression. You also get 4 clauses, but now each one of them has only 1 condition in it. This reduces the complexity, and the overall understanding of the code is better. So this kind of stuff, I think this is the most valuable stuff. I know those methods, the Carnot table, for example, from university, but not everybody was paying that much attention during the lectures, or they didn't attend the same university. So if you can teach them something, and it can have this big impact on the code, I think this is the most, I believe that this is the most valuable comment I had on a pull request in my career. Okay, so that's about that with the samples. Of course, I didn't show everything. If you want to see more bad stuff that you can find in the code and point it out, here's Dariusz Śmigel. He will have a lecture on common mistakes when programming in Python. Please attend. He will probably show some more stuff. And let me just say a few conclusion thoughts. So I believe that code reviews are good. I think they bring value to the project. I hope that the people in the project also don't mind them that much. I believe that the general consensus is that code reviews are good, and if there's somebody that thinks that they are bad, I would very much like to hear their opinion when I will ask for questions at the end of this talk. So code reviews, they help you maintain the code quality and the coherence, so adherence to the standards. They are irreplaceable when there are new people on the team that they either cannot program or they do not know the project yet. It's an opportunity to teach. It's like I'm coming there doing those reviews, and it's a little bit like doing workshops on the code. And also they are very good for knowledge sharing. As I said, everybody in our project, they get notifications about all the pull requests raised, but also about all the comments. And they get an email with the little bit of code that, and the comment that it touched. So if they see use Unicodes here, they will know, oh, I did the same mistake, better correct it before I release the pull request, or they will make fun of me, just like this guy. And also it's a great way to kill time and earn a living. If you don't feel like working during pull reviews, great. And just a few last thoughts, how you can become a good reviewer. Use proper tools. If your tools are shit, you won't be doing a good job because you just can't be bothered. It's very important to have good tools, and they make difference. I was working with the review board and it's not that great. But with private GitHub, for example, I find pleasure in doing those. You need to find time. It is time consuming, it is taking quite a bit of your day, but you should spend some time on it, and you should accept your fate. If you are the guy doing the reviews, well, you have to do it. You won't do that much coding, you won't get that much stories, you'll be doing the reviews mostly, so just accept it and be happy with it. And fight boredom. If you think that you're getting too bored doing the reviews, maybe, I don't know, post some jokes in it or link to some GIFs, I don't know. And most important, I think, is just know Python. If you don't know Python well, you cannot do the reviews well because you don't have that good knowledge, that good opinion. So learn Python. If you are great at Python, you can point out mistakes in people. If you are not, then your comments might not be that valid. Thank you for your attention. Are there questions? Great.
Hi, my name is Roman. So, for reviewer in one of OpenStack project, so I have a bunch of comments, but I'll discuss some of them in private with you, but there are some very important I'd like to notice. So, first you mentioned that you have to take your time and analyze bigger pull requests to make them a good review. I think this is wrong. This is completely wrong because you can never analyze a big change, and you can never find all the problems in a big change. So one of the policies we have in OpenStack is if the change is big enough to be hard to analyze, we just put -1 to that and saying, please split that into smaller changes or 3 smaller changes, which are bringing smaller contribution to the project and are easily to analyze.
Okay, so to answer that, we have a little bit different workflow in our project.
That doesn't change the stuff, so any change could be split.
Let me finish. When you have something that is too big, you are supposed to split it into few pull requests, so you will have partial pull requests. So that's how it's done. And what I meant is that if you get the pull request raised already, it should be the digestible size, and that's what I meant.
All right. So the other important stuff. So you mentioned that you should never run the code, but I think the proper statement is you should never run the code before code review. But you have to run, as a reviewer, you have to run the code after code review, and moreover, you have to run the tests and you have to run the coverage. And
why would I do that? The tools are doing that for me. there's continuous integration that will run the tests, and we have testers that will check if the code is working.
As a reviewer, you are responsible for the code you are letting to go in. The QA engineers, they are not responsible for the code. They are responsible for features. You are responsible for the code as a reviewer. And if you put your signature under some code, you have to be sure it works, because if it doesn't work, your reviews in the future are not as valuable as they should be. So at least you have to run some tests, and at least you have to check the coverage and to see whether those tests cover the changes. Because if some code is intended to fix a bug, and there is no test for this bug, how can you be sure?
Okay, I understand your point of view. Right. I do not agree with it fully. I think it would be a waste of my time to be running tests that the original developer should be running. But I can see the point in that. Okay.
All right, and you also said that the original developer should not comment on the code. I don't think that this is wrong, because the developer should know some corner cases or original design of the system, of all the part of the system or subsystem, and any change to that system might hit one of the corner cases which is not known by the developer of that particular change. And the original developer has to look at that place and see whether any of the problems he hit previously are hit in this change.
Okay, that is valid. I think when you have more collaborators on the project, when we are doing the stuff that we are doing, it's usually like 2 people, sometimes very rarely like 3 people when the third person is the front-end developer doing some changes. So it's a little bit different. Right. But I understand when you have a bigger project, that might be very valid, yes.
All right, thank you.
Okay.
Okay, I'm afraid we don't have enough time for...
One more, because I have one more prize to give. That's for you.
One short question.
One more, please.
Yeah, I think more than a question is like a comment in addition to what Roman said and what you've been talking about. I think a lot of this comes down to how big is the project that you're contributing and how big is the community you're reviewing code for. So in OpenStack, we had a really huge community. We have a multicultural community, and we have to take care of a lot of things there that might hit persons, I don't know, emotions, whatever, will to contribute to the project. And it's an open source project, you know, you want people to contribute to it. So things like commenting a lot on the English or the language for us is English all the way. And you have to be very careful about that. It's definitely, if the comment doesn't make sense at all, you'll probably propose something like a better way to comment on the code or things like that. But sometimes you have to evaluate the trade-off of letting something in that is not perfect, but that would still fix some of the issues that you have. And if it's understandable enough, you won't be so nitpicky on what that person did, because you want to keep your community anyway. It's not like it's not like you're not doing a good code review just because you don't want to hurt I don't know, some people's emotions, but it's just you are evaluating the trade-offs. And there's some code that also introduces probably some technical depth, and you have to also thank you. And you also have to there's some code that might introduce some technical depth, and you might be aware of it, but it's also a good way to, instead of rejecting the patch completely, you could probably say, could you propose a second patch, a follow-up patch that will fix this, since, I don't know, your patch has been around for 3 months already for projects as big as OpenStack, and we don't want to hold your patch any longer, so let's let this patch land, and there are other patches depending on it. And you just propose a new patch that will fix the technical debt, you know.
Yes, it's a valid point that you should not hurt people's emotions, but this is like more a talk about, political correctness and stuff. What can you say and what should you say? It's like a little bit not that much programming, and it's more like, I don't know, marketing, human resources.
I don't know.
More this kind of stuff. So I would not like to comment on that too much. I don't believe that much in political correctness. I think that you should hear criticism if you do some stuff that is wrong. But you are right, you should not be nasty, that's for sure, because
Right,
people
but
will
depending on
just
the project
hate
you're
it.
working on, it matters more or less. You know, like if there are some projects that are huge as big as OpenStack, and you have such a big community, that probably becomes a really important part of the whole code review process that you have to take care of. You might not care about it, but you still have to take care of that.
What I wanted to say is that if you see that somebody has some stuff that would be nitpicking for you to point out, like the language or stuff, then you can just help them a bit, and you can. For example, personally, I did stuff like this. I would some changes on my own to the pull request because I just can't be bothered to make the guy change this little bit, because it will take 15 minutes for me to comment. He read in 15 minutes for him to make a change once again, and I know that this language needs to be changed, and I just push the change myself. So you can just help them to do it. And about rejecting the stuff, I think we don't do stuff that we reject pull requests like completely. We sometimes say that you should rewrite it and try again. And I'm trying to point out how it can be done differently. It's not like I'm just saying this is bad. Is bad. You did a bad job. No, I'm saying this can be done better if you do it like that. I'm trying to point out how I would do it. So trying to give pointers how to do it. But yes, valid point that you should appreciate the people who are committing to the project. Okay, I think that's all the questions. Thank you very much.